Hi everyone, welcome to STEAM Time. My name is Dayna. I'm the Buena Vista Branch Manager with Monterey County Free Libraries. For today's topic, we are talking all about static electricity. Have you ever walked over carpet and then touched somebody and felt a little zap? That is static electricity. Or have you ever walked outside and suddenly your hair stands on end? That's static electricity. Today's experiment, we're going to look at static electricity in action, so stay tuned. We'll walk through what you're going to need and the science behind it. To get started with our static electricity experiment today, you only need a few things. A lot of this stuff you probably already have around your house, so let me walk you through what you'll need. Of course, to test static electricity, we're going to be using our trusty balloons. I was able to find these at the Dollar Tree. It was like a pack of 20 for $1. My son loves to play with these balloons. So you're going to need a balloon. You are going to need tissue paper. I went ahead and cut a single sheet of tissue paper into a smaller square because it's easier to work with when it's a smaller piece. You are going to want to pick a shape to do. If you don't want to do your shape freehand, you can try using a cookie cutter or a stencil and then scissors to cut your shape out. You can also make a tissue paper shape freehand, and then you'll just need something to write or draw with. So that is all you will need to conduct the experiment with me. So before we see it in action, let's talk a little bit about the science behind how this experiment works. Now that we have our supplies all ready to go, let's talk a little bit about the science behind how the experiment works. What exactly is static electricity? Well, when you have items with different charges, positive and negative, they're going to attract. So we have a positive and a negative, they attract. But when you have items with a similar charge, let's say for instance, you have an item that's positive and you have another item that's positive, instead of attracting, they're going to repel. They don't like each other. So think about how magnets work when you stick them together. Do they attract or do they repel? So it's all about the positive and negative charge. Same charge, repel. Opposite charge, attract. So let's talk about how that applies to our experiment. Our experiment, we're going to have a balloon and a regular piece of tissue paper. Now, the experiment asks us to rub the balloon on our hair. We're also going to look at rubbing it on a piece of fabric. So when we rub that balloon through our hair or on wool or a piece of fabric or carpet, what we're doing is we're building up that static charge. We're letting those negative electrons build on the surface of our balloon. So we're letting that build and build until it creates a nice static charge. That's creating static electricity. So some of the electrons that are on our hair or the fabric or carpet, those are then going to move and jump on to the balloon. So what happens is this creates a negative charge, and those negative electrons on the balloon then help it lift lighter objects up to meet it. Those with a positive charge. So that would be our tissue paper. Negatively charged balloon, positively charged piece of tissue paper. So then what happens is the negative charge of the balloon, hopefully, if we do this correctly, is going to help lift the tissue paper up and attract it to it. Because what happens when two opposite charges come together? They attract. So that's how static electricity works for this experiment. Now, once the charge wears off of the balloon, your tissue paper is going to fall right back down. But the cool thing about this experiment is you can just keep recharging it over and over again to do the experiment. So now that we are static electricity experts, let's see it in action. Okay, so it is time to get started with our experiment for today. So what we need to do first, I'm actually going to put my balloon to the side. We want to cut our shape out first. So the important thing is you want to keep your shape pretty small, between 1 to 2 inches, depending. Well, this is a good part to experiment with. Do smaller shapes or larger shapes attract better to the balloon? That's something to play around with. But I'm going to start by creating a shape that's about 1 to 2 inches in size. I just made a star. So you want to cut that out for time purposes. I went ahead and already cut out my shape. You're going to lay it on a flat surface. That's all you need to do. Then, of course, you want to grab your star of the show, your balloon. You want to blow it up and then tie it off. That, for some reason, is the most challenging part, I will say, of this entire experiment, is getting balloons tied. So once you have successfully blown up and tied your balloon, now it's time to get that static electric charge all built up. We want those negative electrons on our balloon. So I would recommend rubbing your hair for 10 seconds, if not longer. Again, experiment with the time. What happens when you rub your hair for 10 seconds versus 30 seconds? Does that make a difference? So if it works correctly and we get enough negative electrons on our balloon, we should be able to make the positive electrons of our tissue paper float up to meet it. Are you ready? Okay, on the count of 5, let's get charging. In 5, 4, 3, 2, 1, and rub. Oh, this is gonna give me a horrible hair day. That's okay, all for the sake of a video. Okay, rub, 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 rub. Let's see, has that been a good 10 seconds? Maybe, give it a couple more seconds. And let's get ready to test. Are you ready? Okay, and it's coming. It's trying to. Come on. The star wants to lift. Come on, little guy. Okay, it's starting to float. Let's do that one more time. Are you ready? Get your balloon ready. Make sure your shape is flat on the table. Let's get charging. Okay, are we ready? That should be good. I'm getting those negative electrons, and let's put it over our shape. It wants to lift. Let's give it a little. Ooh, oh, that one actually tried to dance up to meet it. So it does. It's starting to levitate. Now let's see what happens when I cut it a bit smaller. Let's actually cut our shape in half. We're working with a smaller piece. Let's see if that makes a difference. Are you ready? Okay. Okay. Build up that static electricity, and here it comes. Oh, that jumped. Very cool. And if you see, the tissue paper floated up. That one actually kind of jumped onto the balloon because they have opposite charges, and opposite charges attract. Thank you so much, everybody, for joining me for today's STEAM time and testing out our static electricity experiment. After it's done, you have a balloon to play with, but it's also a really fun one to do for different holidays. I've done this one with orange tissue paper. We made little pumpkins, and then we made our little pumpkins dance around and float around. So it's pretty fun. use your imagination, be creative, and have a lot of fun making your shape float with the help of some static electricity. If you're interested in more science topics like this, definitely check out our online catalog at emcfl.org, place a hold, and then pick your item up at your local branch through our curbside service. You also can call our library, 883-7555, and talk to a phone team member who would be happy to help you bundle different science books together so you can do more science experiments at home. Thank you so much, everybody. I look forward to seeing you next time. Bye. Take care.